Okay, welcome back to another video on the Maths channel. It's your teacher, Miss Lim here, and in this video we're going to be looking at radian measure of angle size. So by the end of this lesson, you'll be able to define what a radian is, convert between radians and degrees, and use special angles to evaluate trig functions. So let's have a look at the first part of the lesson. What is a radian? Now, if we were to create a sector, let's say that this has a radius of 10, okay, let's say 10 centimeters, and let's just say that this angle here is 20 degrees. Okay, if we wanted to work out the arc length, we can, right? It's just the arc length, L, is equal to the fraction of a circle times the circumference of a circle, right? 2 pi r. 2 pi times the radius of 10. We can work that out as 20 over 360 times 2 pi times 10, which is 3.49. Okay, 3.49. Now, of course, this is not to scale, but you get the idea. Here we've got the angle of 20 degrees, but a radian is a special angle where the angle will actually create an arc length which is the same as the radii. So we want this to be 10 centimeters. So instead of thinking of it as like an equilateral triangle, think of it like as an equilateral sector where all three sides are the same length. And this angle here, that is 1 radian. Okay, so the angle formed between 2 radii, where the arc formed in between them is also the length of 1 radius. That's called a radian. Now I'll try and make this a little bit better. So if we've got 1 radius here, and we were meant to work out that the arc length is also the same length as the radius. That's the radius. Then here, that is 1 radian. So you might be asking, how many radians are there in a full circle? Well, that's a really good question to ask. So if we were to continue this, well, that's another radius, right? And then again, that's another radius, and then again, that's another radius, and another radius, and another radius, and then there's a little bit left. So you might be wondering, how many radians are there in a full circle? Well, the question you could ask yourself is, well, how many radiuses or radii are there in the circumference of a circle? Right, in the circumference of a circle. Well, we actually know that. We know that the circumference of a circle is 2 pi r. Right? 2 times pi times the radius. That's how many radiuses are in the circumference of a circle. 2 pi radii. Therefore, there has to be 2 pi radians in a full circle. If I can spell properly. Full circle. So that's 1, 2, 3, 4, 5, 6, and a little bit. Well, 2 pi, if we put that in our calculator, 2 pi is 6 and a little bit, 6.28. So that means this little bit here must be about 0.28 radians. Okay, so I hope that makes sense of what a radian is. The radian is the angle that's formed when the arc length is the same length as the 2 radii. Okay, let's have a look at the second part of this lesson, which is converting between radians and degrees. Now, if 2 pi radians is equal to 360 degrees, right, so we scroll back up here, we know that that here, that's 2 pi radians, but also that's 360 degrees. Well, if 2 pi radians is equal to 360, then pi radians is equal to 180 degrees. And this is really important. I would probably memorize this one. I don't think that you need to memorize both, but this is probably the most useful one. It's useful for converting between radians and degrees. So let's have a look at this. If we want to convert radians to degrees, substitute 180 degrees wherever you see pi, and then evaluate it. That's the easiest method. However, if there's no pi, then divide the angle by pi, and then multiply by 180. So that second sentence there actually works in substitution for the first one. It's just that the first one's probably easier to do. Okay, so let's have a look at this one. We've got question A is pi radians, so wherever we see pi, just substitute it with 180. So that's just 180 degrees. Question B, we see pi on 2, that's the same as 180 divided by 2. That's 90 degrees. Okay, I'll do one more with you. Pi on 3, substitute 180 divided by 3, that's 60 degrees. Okay, what if we want to convert degrees into radians? If we want to convert degrees into radians, divide your angle by 180 and then just put pi in the numerator. What do I mean by that? So here we are going to do 135 divided by 180 and then put pi in the numerator. So 135 over 180 is 3 over 4, so that's 3 pi over 4. Or here we've got 60 over 180 and then put pi in the numerator. Well, 60 over 180 is 1/3, so that's equal to 1 pi over 3. 210 is 210 over 180, put pi in the numerator. But in our calculator, we don't put pi, we just put the fraction, so we can simplify the fraction. 210 over 180, that's 7 pi over 6. Okay. I'm going to get you to pause the video and have a go with questions D to J, and when you're ready to check your answers, I'll get you to do that. Okay, so here are the answers for question D to J. You can feel free to pause the video so you can check your answers. Alright. Let's have a look at the last part of this lesson, using special angles to evaluate trig functions. Find the exact value of the following trig functions. So here we've got sine 5 pi on 4. What I like to do is, I actually like to convert these radians to degrees first. So here we've got sine 5 pi on 4. So we'll do 5 times 180 divided by 4 is 225. So technically I want to find what sine of 225 degrees is. Now if I were to my all stations to central, I know that 225 degrees lies in the third quadrant, and so if this is 225 degrees, the reference angle has to be 225 minus the 180. So this reference angle, 225 minus 180, is 45 degrees. That's 45 degrees. So I know that this bit here is 45 degrees. And with my unit circle, I know that this is going to be root 2 on 2, comma root 2 on 2. That's the coordinates of that point there. Now 5 pi on 4, 225 degrees. Over here, we're going to have exactly the same coordinates, root 2 on 2, comma root 2 on 2, except in this quadrant both x and y are negative. So I'm going to put negative signs for both of them. Okay, So now that I've done that, I can actually work out what sine of 225 is. Well, actually that's cos and that's sine, so it's equal to negative root 2 over 2. Okay, and I can double check this using my calculator. So if I were to do sine of 225, I get negative 0.707. Good, my s is negative. If I were to get negative root 2 over 2, yep, negative 0.707. So I know I got it right. Okay, let's have a look at question B, cosine of 2 pi over 3. So I'm just going to put that in my calculator. 2 times 180 over 3, because I want to convert that to degrees. That's cosine of 120 degrees. Alright, let's bring out our all stations to central. 120 degrees is about here. That's about 120. Which means that this bit here, this is the reference angle, right? Always between the line that we draw and the x-axis, the horizontal. So this has to be 60 degrees. Which means that the reference angle here, that has to be 60 degrees. Alright, let's draw in our unit circle. 60 degrees is half comma root 3 on 2. And we can see here that cos is equal to half. However, for this one over here, we've got half comma root 3 on 2. The x value on this side of the Cartesian plane is negative, and because that's cos, this has to be negative half. Right, question C. Tan of 7 pi on 6, again, I'm just going to convert this to degrees. So we have 7 times 180 divided by 6 is 210. Tan of 210 degrees. $210, that lies around here, where this reference angle has to be 210 minus 180, which is 30 degrees. So 30 degrees here. I know that this is going to be root 3 on 2 comma half. So that means over here, this is also going to be root 3 on 2 comma half, except they're both negative. Okay, x and y values will be both negative. Okay, so if we want to work out tan is sine over cos, sine 210 over cos 210. Well, sine is negative half, cos is negative root 3 on 2. So the negatives cancel each other out, the 2's cancel each other out. So I'm left with 1 over root 3, or root 3 over 3. Okay, we can check our answer. Tan of 210 is 0.577. And if we have root 3 over 3, 0.577. Good. Alright, let's have a look at question D. Cosecant 4 pi on 3. So we'll look at 4 pi on 3. 4 times 180 divided by 3 is 240. So we've got cosecant of 240 degrees. All stations to central. 240 degrees is probably around here. So that means this angle here has to be 240 minus 180, which is 60 degrees. That's 60. So that means we're looking at this one, 60 degrees, which I know is half comma root 3 on 2. So that means here we know that this one is half comma root 3 on 2, except they're both negative. Okay, now cosecant is 1 over sine. So we want to know what sine is. Sine is negative root 3 on 2. And so now we can just do the reciprocal, and this 2 goes to the top, so it becomes negative 2 over root 3, or negative 2 root 3 over 3. Okay, let's check that. Cosecant is 1 over sine, so we have 1 over sine 240, negative 1.155, and if we do negative 2 root 3 over 3, negative 1.155. Excellent. Alright. Why don't you pause the video and have a go at questions E and F by yourself. Okay, so here are my answers for questions E and F. E, secant of pi on 6 is the same as secant of 30, or 1 over cosine 30. Okay, remember the third letter tells you what it's 1 over. The third letter is C, so it's 1 over cosine. You draw up your unit circle. You know 30 degrees is root 3 on 2 comma half, and we only want cosine, so that's the first bit. So 1 over root 3 over 2, do the reciprocal, and you get 2 over root 3, or 2 root 3 over 3. Question F, we've got cotangent, so t, 1 over tan. Cotangent of 7 pi on 4, well 7 pi on 4 is 315 degrees. Another way of writing a cotangent, instead of saying 1 over tan, I'm going to do cos over sine. So cosine over sine instead of, because tangent is sine over cosine, so cotangent has to be cosine over sine. So all stations to central, 315 degrees gives me a reference angle of 45 degrees. Okay, always between the line you draw and the horizontal. Well, I know 45 degrees is root 2 on 2, comma root 2 on 2. So 315 degrees, the coordinates will be root 2 on 2, comma negative root 2 on 2, because the y value is negative, x is positive. So cosine over sine will be root 2 over 2 over negative root 2 over 2. Root 2's cancel, 2's cancel, we're left with just negative 1. Right, so now you should know what a radian is, be able to convert between radians and degrees, and actually use trig values, or use special angles to evaluate trig functions. Okay, and that's it for this video.